All right, let me ask you something. What if you could solve a problem by looking at every single possible answer, all at the exact same time? It sounds kind of like science fiction, right? Well, today, we're going to unpack a revolutionary new way of thinking about AI that does just that. And honestly, it could change, well, pretty much everything.
Seriously, just picture it for a second. You've got a problem with trillions, that's trillions with a T, of possible solutions, but only one of them is the right one, the perfect one. I mean, where do you even begin? This isn't just some brain teaser. This is the huge, fundamental hurdle that today's AI is desperately trying to clear.
So, to really wrap our heads around this, the source material we're looking at gives us this really great analogy. Let's just imagine a maze, but not just any maze. Think of a massive, incredibly complex one. It's got one way in, one way out, and just a mind-boggling number of dead ends and wrong turns. Okay, so in this picture we're painting, the maze itself, well, that is the problem we're trying to solve. And that one perfect path, the one that gets you from the start to the finish without any backtracking, that's it. That's the best, the optimal solution that we're looking for.
And look, this isn't just some abstract thought experiment. These mazes are real. They're the super high-stakes problems we face every day. We're talking about things like designing the exact molecular structure for a life-saving drug, or figuring out how to optimize a financial portfolio for the absolute best return, or even finding the single fastest route for a global shipping company. The stakes are huge.
Right, so how do we solve these things now with today's AI? Well, the classical or old-school approach, it's kind of like sending one single runner into that massive labyrinth and just hoping for the best.
So picture this, lone runner standing at the entrance. They've got no map, no compass, no hints whatsoever. All they can do is pick a path and start running. It's all just trial and error, a complete brute force attack on the problem.
And yeah, the process is methodical, but man, is it slow, painfully slow. The runner goes down one path. Oops, dead end. The AI makes a note. Okay, don't go that way again. Then it has to backtrack all the way to the last intersection and try a different path. And it just does this over and over and over again.
So here's the bottom line, and our source material really drives this home. This whole process is just incredibly slow and inefficient. For the kinds of massive real-world mazes we're talking about, this one-by-one trial and error thing, it could literally take forever. We're talking an eternity.
Okay, but what if there was another way? What if we didn't have to depend on that one lonely runner? This is where the new approach, quantum AI, comes in, and it is a completely different ballgame. Forget the runner. Instead, imagine unleashing a giant wave into the maze. And yeah, this is where things get a little weird, but stay with me.
Think about it. What if you didn't have to go down just one path at a time? What if you could basically flood the entire maze? I mean, send something down every single corridor, around every single turn, all at the exact same moment. Well, believe it or not, this is possible. It's thanks to a really core principle in quantum mechanics called superposition. Now, in simple terms, this just means that a quantum particle can be in a bunch of different places or states all at the same time. So for our maze, this wave we're talking about can actually flow down every single path simultaneously. No stone left unturned. Nothing is missed.
But wait, because exploring everywhere at once is only half the magic. The second ingredient, the real key here, is something called quantum interference. The best way to think about it is like ripples on a pond. Imagine all these waves moving through the maze. When the waves from the bad paths, the dead ends, run into each other, they actually cancel each other out. They just disappear. But the waves traveling down the right path, they build on each other. They get stronger, bigger, and clearer.
And the result of this is, well, it's just incredible. The quantum system doesn't have to learn from its mistakes in that slow, step-by-step way. The mistakes, all those dead ends, literally just erase themselves. Poof, gone. And what you're left with is the one single correct path, lighting up like a beacon. The solution just reveals itself, almost in an instant.
Okay, so let's zoom out for a second and put these two ideas, the runner and the wave, right next to each other. Because when you see them head-to-head, you really get why this difference is such a massive deal.
All right, let's break this down. On one hand, you have the classical runner. It's sequential, one path at a time. It learns through slow, painful trial and error, and it's super inefficient. On the other hand, you have the quantum wave. It's simultaneous, all paths at once. It learns through this magical thing called interference, and the result? It's practically instantaneous. It's really the difference between brute force and just pure elegance.
Here's another way to think about it. The old way, the classical way, is like having a giant ring with a million keys and a million locked doors. You have to try every single key in every single lock, one by one. The quantum way? It's like you hold up some kind of magic lens, and the one correct lock just instantly starts glowing. The difference in speed and efficiency, it's just staggering. It's not even in the same league.
So, what's the big picture here? What does this all mean for us in the real world? Because this isn't just some cool physics concept, right? This has a massive, massive impact. Let's talk about that.
And this is the real takeaway. Quantum AI isn't just a slightly faster computer. It's not just an upgrade. It is a fundamentally new type of tool for solving problems. It holds the promise of tackling challenges in medicine, finance, you name it. Problems that are so complex, so massive, that even our best supercomputers today just throw their hands up and say, nope, can't do it.
And that leaves us with a final and pretty mind-blowing question to chew on. If we actually have a tool where all the wrong answers just disappear, what giant mazes, what once impossible problems could we finally solve?